Yo, we got ourselves a related rates problem here. It is an observer stands 400 feet away from a launch pad to observe a rocket launch. Well, that means we're going to start off with putting some ground, and we're going to put a launch pad right here. Okay, there's our pad, and we got our observer. He's over here. He is going to watch the rocket take off. Here's our rocket. It's going to go up in that direction. Now the rocket blasts off and maintains a velocity of 600 feet per second. Okay. Assume the scenario can be modeled as a right triangle. Okay, well, here we go. It looks like we've got a right triangle situation. That's fine. Now, how fast is the observer to rocket distance changing? Observer to rocket distance changing. Well, if the rocket eventually makes it up here, then the distance from the observer to the rocket, I can call that distance, how about we use x? Now, we want to know how fast is that distance changing. So when they say how fast is a certain thing changing, that's the derivative with respect to time. So we're after dx dt, but then it says when the rocket is 300 feet from the ground. Okay, so how about I call this y, and then we'll say when y equals 300. Now, by the way, there's 400 that I should have got in here right at the beginning, because it said that the observer is standing 400 feet from the launch pad. So 400 goes right there. Okay, so what do I want to start with? I want to start with an equation. And an equation that will always be true no matter what x and y is. And that equation would be Pythagorean's theorem. So we could say that x squared equals y squared plus 400 squared. So I might have wanted to choose a different variable, but I put x here because that's the thing I'm ultimately after. But this is a squared plus b squared equals c squared. Okay, so now that I have this equation, I don't want to plug in anything right now. Before I plug in, I always want to take the derivative of the equation that I made. So if I take the derivative, I'd be taking the derivative with respect to time. So d by dt on both sides. So the derivative with respect to time of x squared is 2x times dx dt. So that's the important part right there. It's not just 2x, because now we're putting a t on the bottom. In the past, we used to put an x on the bottom, but now there's a t on the bottom, so you also need this extra thing times the derivative of x with respect to t, or just dx dt. Same story on the other side. It's not just 2y, it's 2y times dy dt. And now, if I'm trying to figure out what dx dt is, then that's right here. And I just need to plug in everything else. So I know that y is going to be 300 at the moment we care about. So I've got 2 times 300. Now, what about dy dt? Well, the thing is, they told you that dy dt is 600. That is how fast the rocket is going upwards. So y is the distance between the rocket and the pad. So that means dy dt is the rate at which that distance is changing, which is the velocity, which is 600. So we're going to put that 600 in right there. And then that is all equal to dx dt times 2x. Well, x is an interesting one because x requires me to do Pythagorean theorem when y is 300. So I got to go back to x squared equals y squared plus 400 squared. And I plug in the 300 that I was using for y. So it gets plugged in right there. So I put that in. So it's going to be 300 squared plus 400 squared equals, well, if you're super good with your 3, 4, 5 knowledge, you'll know that x would have to be 500. 3, 4, 5 or 300, 400, 500. Turns out that works too. So now we know that x must be 500. So we're going to take this 500, we're going to pop that in where the x goes. So right over here, I'll put 500. It turns out there's a 2 on both sides, so that cancels. And now you're left with 500 dx dt equals 300 times 600. Now you want to divide both sides by 500. And we can cancel out these zeros here. So we're just left with 3 times 600, which is 1800, over 5. I hate dividing by 5, but I love multiplying by my 5 by 2 to turn that into a 10. Multiplying the top by 2 as well. And that would be 3600. And now I'm dividing by 10, so I could use that zero trick. All right, so that gets you 360. And the units are feet per second. So dx dt is 360 feet per second. What a awesome problem. Hopefully you can also blast off with your math knowledge. Bye-bye.